Hi students, let's look at this question here, which is on P&C. Let's say we can do this proficiently. So a shop has 7 mountain bikes, bicycle of 5 different brands, 5 racing bicycle of different brands, and 8 foldable bicycles of different brands on display. A cycling club wishes to buy 6 of these bicycles. They are all different, they're all distinct, okay? So how many different selections can you make if there be no more than 3 mountain bikes and no more than 2 each of the no more than 2 of each of other types of bicycles, okay, that you need. Okay, let's just slowly do this part here. The first thing is I'm going to write down all the different numbers of bicycles we have here. So we have got mountain bicycles, so mountain bike, and there will be 7 mountain bike. So maybe I just put this mountain. Okay, we have 7 of it. After which, a racing bike, racing will be 5 of it. All right. Then we have got foldable, which is like 8 of it. Okay. So what we need now is to select now is how many different selections can we, if there must no more than 3 mountain bikes and no more than 2 each of the other types of bicycle. No more than 3. So mountain bikes could have no more than 3, meaning we can have 0, 1, 2, right? This is no more than 3. Is it no more than 3? And 3. Okay, we can have this bikes here. So apart from that, so these are the first one, which is we could take 0, 1, 2, 3 for the first no more than 3, right? So it can be 0, 1, 2, 3, and no more than 2 each of other types of bikes. So meaning we kept all these at 2. Great. So let's look at how we can have 0, 0, but how many total bikes? 6. We should buy 6. So you could cap at 2. So meaning to say no more than we should buy 6 of these 20 bikes. Okay, 6, right? You need to buy 6. So we need to be no more than 2 each. Okay, so meaning to say if you want to get 6 in total has to be 6, right? So you can't, this is impossible. Okay, because we are all capped at 2 here, so you can't get 6 bikes here. So this is not possible. Okay, this is not possible. Here is not possible as well because we cap at we actually cap at 2 for racing and foldable. So at most we would have 5. Okay. Now this would be possible. So one of these would just be, if this is 2, then this will be 2 and 2, right? Cap at 2, no more than 2. So this is possible. So 6 will be here. But this is only if mountain bike is 2, you have to take 2 from racing and 2 from foldable to make up to 6. You can't take 1, so it's fine, right? So if mountain bike is 3, this case here, you can have 0. Let me see first. Basically, we would have we need 2 cap at 2 here, so you can have 2, and this will be 1, right? But of course, this is not the only case where we get 6. We could also have 3, 2, and 1 here. Okay, so this will be a total of 6. So total 6 by anything else we left out. So 2, 2, 2, 3, 1, 2, 3, 2, 1. Is that a 3, 0, 2? We can't get 3, 0, 2, right? No more than 2. So 3, 1, 1. Oh, we could also have no more than 3 mountain bikes. Okay, I think that's about it. Any more cases which I did not consider? Yeah, so these are the 3. So for this case here, what we get is actually this will be 7 choose 2, 7 mountain bike choose 2, 5 racing bike choose multiplied by 5 racing bike choose 2, and the last one with 8 racing bike choose 2, adding with 7 choose 3, multiplied by 5 choose 1, multiplied by 8 choose 2, plus 7 choose 3, multiplied by 5 choose 2, Times 8, choose 1. Okay, so add all these up together. What we'll get is the answer there. Key in calculator. You will get 13580. So 13580. Alright, so that's how we do this part here, part 1. So for the second one, the cycling club decides to buy 3 mountain bikes, 1 racing bike and 2 photo bikes, and park them on a bicycle rack which has a row of 10 bicycles. So 10 bicycle lots. How many different arrangements can the bicycle club arrange the bicycle on the bicycle rack if all the mountain bikes are together and both the foldable bikes are together and the empty lots are together? Great. So I think it's pretty okay. So you need 3 mountain bikes to be together, 1 and 2 foldable bikes. There are 10 lots, right? So you draw out 10 lots first. Here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. After which, what we need to do is foldable bikes together. There are 2 foldable bikes, right? 2 foldable bikes together. So I'm gonna put this as foldable bikes. Then mountain bikes are together, which is 3, and empty lots will be 4 of the empty lots. There are 4 empty lots and 1. So I'm gonna write this down. This is foldable bikes. Okay, and 2, then 3 mountain bikes. And after which these are empty lots. Okay, empty lots, just treat them as identical lots here. So the number of ways to arrange it. Okay, would be the outer layer here, meaning you have got 1, 2, 3, 4. So this is 4 factorial. So 4 factorial multiplied by this is 2 factorial here. 2 factorial, and this is 3 factorial. Okay, so we have 2 factorial multiplied by 3 factorial. Okay, empty lots, you don't need to arrange them because they are all identical. So that's about it. This is your answer here. So the answer will be 288. Right, so arrange the outer layer, the inner layer. These empty lots here, they are just 4 factorial over 4 factorial because they are identical, but you don't really need to write it down. It's quite redundant actually. Okay, then this will just be your this will be your racing bike. Great. Let's look at part 3. How many different arrangements are there on the bicycle rack if the foldable bicycles are end of the bicycles and there are no spaces between the bicycle? So part 3, we're going to draw out 10 empty spaces first. So we have got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that will be how many bicycles we have? We have got 3, 1 plus 2. So we have got 6, right? 6 bicycles here. 6 bicycles. So 6 bicycles, they are supposed to be together. So in this case here, I'm going to draw it out. 6 bicycles, 2, 4, 6 here. And this is foldable bike, foldable bike. This is foldable bike. This is foldable bike. Okay, that's about it. And these are all empty slots. Okay, empty. Okay, so this case here, empty slots, just do it like that. And this is obviously 4 factorial in the middle, right? 4, calculate 4. And foldable bike at both ends here, this will be multiplied by 2 factorial. So the number of arrangements, ways of arrangements, okay, will be the outer layer, which is 1, 2, 3, 4, 5. Okay, the outer entities will be 5 factorial, and will just be 5 factorial. There are 4 identical empty slots there. Then in the middle of this, we have 2 factorial multiplied by 4 factorial. Okay, so just key in calculator, this will be actually 5 factorial multiplied by 2 factorial. So 5 factorial times 2 will be 240. Am I right? Okay. So this is how you 5 factorial times 2 4 5. Yeah, so that's how you do this question in Proficiently. So any question at all, please let us know. Keep practicing and I'll see you in the next question.